Everybody has heard the phrase work smarter, not harder. Well, in science and engineering, we actually have a mathematical term for this, and that mathematical term is mechanical advantage, or MA for short. And the definition of mechanical advantage is just the advantage you gain by using one of these simple machines, so gained from a machine. And there's something we need to make clear from the get-go on mechanical advantage and machines, and that is machines don't make the work you are doing any less. So don't make work less, and let's widen this out just a little bit, I think. But instead, they simply give you an advantage in doing that job. So let's use an example to explain what we mean when we say advantage. And so let's start with just a simple job to do. All right, so let's say we need to lift some 40-pound weight. Okay, and let's just say it's a box, this 40-pound box. And we need to lift it up. So let's draw a person to pick it up. Give him 2 arms and 2 legs. He's going to pick up this weight, and he's going to place it on this platform here. And let's say this platform is, I don't know, let's just say it's 5 feet tall to keep our math simple. And his job is to lift up this weight and place it on top of this platform here. Okay, well, what is the work that he has to do to make this happen? Well, the formula for work is pretty simple. It's just work equals force times distance. And we happen to know what both of those are. We know the force is just 40 pounds, so this is a pretty straightforward question. And we know that the distance is just 5 feet. And so to figure this out, we'll just use our handy-dandy calculator. We'll just type it in. We'll say, what's 40 times 5? And hopefully you can just do that in your head, but it's not too hard. But just in case, we use our calculator, and we get 200. And so the work being done here is 200 foot-pounds. What do we mean when we say the work being done is 200 foot-pounds? Well, we mean that it takes 200 foot-pounds of energy to get this box up on top of that platform. And so this is the work it takes to, or the energy it takes to make this happen. Okay, so what if we used a machine? And what if we used the simplest machine of all? What if we look around the corner and we see there's just an inclined plane or just some ramp to go up? At least I say the simplest. It's the simplest in my mind. It's the easiest to work with, it's the easiest to picture because you can literally see the advantages and disadvantages in the system. And let's say this ramp, though, let's say it's 20 feet long. And we say, well, how about instead of just lifting it up on top of this platform, what if we just took it and pushed it up this ramp to get it on top of the platform? So we just pushed it up instead. And so this box is still 40 pounds, but now we're going to push it up the ramp, which requires the same amount of energy to get this job done, right? It's the same amount of work to get this job done, and that is 200 foot-pounds. But now we're going to go a longer distance. And if you think about it, it's kind of obvious. To push it up a ramp versus to pick it straight up, one requires a lot less force. And so let's see what that force is. Well, okay, we'll just call it force 2 for now. It's the same job getting done. We're still getting this box up here. But what is that force? Okay, well, to figure that out, we know the work and we know the distance we'd be traveling, so we can figure out what the force would take to make this work happen across this distance. So we'd say 200 foot-pounds equals 20 feet multiplied by the new force, this smaller force, which we're just calling force 2. And so it's just a simple algebra equation at this point, right? We just divide by 20 feet on both sides. So we divide by 20 feet over here, we divide by 20 feet over here, feet cancel out, 20 feet over here cancels out, and 200 divided by 20, hopefully you can do that in your head, but if not, just in case, let's go ahead and type it in our calculator. What's 200 divided by 20? Well, it's 10. And again, hopefully you can just do that in your head, but we're left with force 2 clearly equals 10 pounds. And of course, that makes sense. It would require a lot less force to push it up a ramp than it would just be to pick it straight up. And if we know the energy it takes to make that job happen, we know the work it takes to make that job happen, and we're pushing it a further distance, but it's the same job, then wouldn't the force be much smaller because, I mean, work is just force times distance. And so we have two different scenarios where we're making the same job happen, the same work happen, and one we just do the job, and the other we use this sort of machine that gives us some sort of advantage. And the question becomes, what is that advantage? And for that matter, what is the disadvantage of using the system? Because there's nothing you can't just make something help you without giving up something in return, right? You have to actually give up something. Let's talk about what both of those things are. And if we look, the advantage to the system, this inclined plane, let's say, is pretty obvious. It's a much smaller force. So the advantage we're getting is a force. And what do we mean when we say it started out as 40 pounds? This is a 40-pound weight, but because we're using this system, that force turns into just 10 pounds. Okay, so that's a 4-to-1 ratio. So the advantage we're getting is 4 times, or 4 times less, the force. So we could say it equals 4/1, or we could just say a mechanical advantage, or the advantage is 4 times. And so what is the disadvantage? Is there a disadvantage? Well, I would argue there is, because if you look, we started out just going straight up. We just lifted this thing straight up, and we said, okay, well, that went 5 feet. Now we have to push it a distance of 20 feet. So the disadvantage of the system is pretty obvious. It's distance. And well, let's make this very clear. We end up going 20 feet in our inclined plane, but the original job only required us to go up 5 feet. So we went from 5 feet to 20 feet, and I drew this backwards on purpose just to make our ratio we can draw out a little simpler. But the ratio is still a 4-to-1 ratio, or we could just say the disadvantage is 4 times. So let's actually draw that equal sign a little bit better. But the disadvantage is we have to go 4 times the distance. And so when we say it's a mathematical term, what we mean is, I mean, it's literally, it's a ratio or a fraction, or just, I mean, 4 is still a fraction. We could just say that's 4/1. But it is some mathematical term, and that is the advantage and disadvantage you gain from the system. And that is basically all mechanical advantage is, using some machine to get some job done and give you an advantage while doing that job.